The next example out of 3.3 again asks us to fully factor a polynomial. In this case, the polynomial is a little trickier to factor in that, first of all, it's fourth degree, and second of all, the constant term is negative 36. So if I'm going to start trying numbers here, I'm looking at anything that goes into 36. That's a lot of possibilities. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12. All of these numbers could be possible factors for me to try. So to cut that list down a little bit, you might want to use the graphing calculator to just graph this as a polynomial. Graph y equals x to the 4 plus 4x cubed minus 5x squared minus 36x minus 36, and just find some of the zeros. And right away, you should find, at least a couple of zeros there. And you'll find that, negative 2 is a 0, which tells me that x plus 2 is one of my factors. There are others. I could also find that x plus 3 is a factor since the graph goes through negative 3, etc. But as soon as I have a couple, I can use that to my advantage here to even algebraically do the rest of this. So synthetic division I'm going to set up to divide by one of these factors I found with my graphing calculator. So again, I'm going to do synthetic division to divide this polynomial by x plus 2. Where I got x plus 2 from is I looked at this little graph, and I did it on a calculator, and saw that it did go through negative 2, went through negative 3, went through positive 3, so I actually know some more of the factors, but let's keep going with this division. Bring down the 1, multiply, subtract, 4 minus 2, then multiply, subtract, I get negative 9, multiply, subtract, I get negative 18, multiply, I get negative 36, get a remainder of 0, which was what I expected, so I know that x plus 2 times x cubed plus 2x squared minus 9x minus 18 is equal to my polynomial. But I also know more factors. Like I said, I know that x plus 3 is a factor. So if I do synthetic division again, 1, 2, minus 9, minus 18, and I decide to divide this thing by x plus 3, carry out a very similar set of steps here. Multiply, subtract, multiply, subtract, multiply, and subtract. Again, I get a remainder of 0, so it means that so far I still have the x plus 2 from before, I've got the x plus 3 that I just used, and I've got x squared minus x minus 6. Now, rather than go into synthetic division again, this is a quadratic that I should have learned how to factor much faster than that. To say what do numbers multiply to negative 6 and add to negative 1, and I've got x minus 3 and x plus 2. So the polynomial is fully factored. Some people prefer to write the x plus 2 squared times x plus 3 times x minus 3, but that expression is equal to the quartic or fourth degree polynomial we started off with.